Hello and welcome. In the last videos, you learned how to train your own deep learning-based classifier with MVTec HALCON. In this video, we will check out different methods that can help you evaluate whether this trained classifier is reliable enough for your application. During the training, the best classifier was saved according to the validation error. Here we read this classifier. Additionally, we read all the data we used in the training program. Since we use the same random seed, the split is the same as before. Then we read all validation images. Next, we apply the classifier to these images. From the result handle, we get the classification result for every image. Then, using these results, a confusion matrix provides a nice way to visualize the differences between the user-defined ground truth labels and the predicted classes. Here, we can see the correctly predicted objects on the green diagonal. The off-diagonal values show us the incorrectly classified images. For example, this value tells us that 4 images that were labeled as crack were incorrectly classified as good. The incorrectly classified images can be queried with this procedure. Thus, we can check whether some images are labeled incorrectly or investigate why the classification is not yet ideal. For example, here, all these cracks are not detected correctly. To improve this, we might want to add more images of this sort to the training. Additionally, we can use image augmentation, but that's a whole nother story. With the procedure Evaluate DL Classifier, you can compute some common measures that can be used to evaluate a classifier, like the top K error, the F-score, precision, and recall. Here, we achieved an F-score of 0.98. Using, for example, the test images, we can also visualize those areas of an image that influence the confidence of the class assignment the most. This so-called heat map can be used to evaluate the trained classifier. However, it is not recommended to use it for segmentation. This concludes this tutorial on evaluating your trained deep learning-based classifier. For more information on deep learning with HALCON, have a look at the introduction of the chapter Deep Learning Classification within the operator reference. Now, you can apply everything you have learned and adapt the examples for your own image classification. Thank you for watching.